Hi kids, and welcome to lesson 4.02. This is going to be some algebra with our parallel lines and transversals that we discussed in the last lesson. You have a warm-up today. This goes with our last lesson. Notice you do have parallel lines for both questions, and they are crossed by a transversal. So I want you to name the angle relationship here, and then tell me what that angle relationship means. Use it to set up your algebraic equation and solve for x. Do that for 1 and 2. Pause the video and come back and check your answers. You should have had that these were corresponding angles because they're in the same position on each intersection. They're in the top right corner, and they are congruent, so you set them equal to each other. These are on alternating sides of the transversal, and they are outside of your parallel lines, so these are alternate exterior. They're also congruent, so you set them equal to each other and solve. Kind of a wrap up from our last lesson. In geometry, a line, segment, or ray that intersects two or more lines at different points is called a transversal. So here's our transversal that is crossing over lines L and M. So AB is an example of a transversal. There are all kinds of angles formed at the points of intersection. We have alternate exteriors. We have alternate interiors. We have corresponding. We have same side exteriors, same side interiors. We also have vertical angles, and we also have linear pairs. For instance, 5, 6, 6, 7, 7, 8, 8, 5, 1, 2, 2, 3, 3, 4, and 4, 1. Okay, there are 8 angles formed, and we give them special names. We have our alternate angles that lie on opposite side of our transversals, interior angles that lie between the two lines. Our alternate interior are on opposite sides inside, and they are congruent. Our same side interiors are on the same side of the transversal, and they are supplementary. Same side angles on the same side of the transversal. Exteriors are outside. So now our alternate exteriors are on the opposite sides of the transversal, and they're outside the lines. They are congruent. And our same side exterior angles are also supplementary. So here is kind of a wrap up, and we're going to use these little shorthands to name our angles. So now you're either going to be congruent or you're going to be supplementary. Those are the only two choices. So you're either going to be setting your angles equal to each other, or you're going to be adding them together to equal 180. All of these, your alternate interiors, alternate exteriors, your corresponding angles, and your vertical angles, those are all congruent. Set them equal to each other. Your same sides are supplementary. You add them together and equal 180. And then there's the line, linear pair. Every line is 180 degrees, linear pair. They add up to 180. So now take a look at this. I've got a couple of sets of parallel lines. It tells me that S is parallel to T. So these two are parallel, making this a transversal and this a transversal of parallel lines. And that C is parallel to D. So I've got C parallel to D. So now these are transversals of these parallel lines. Name all the angles that are congruent to angle 1. So I first marked angle 1. Okay, I'm vertical here, corresponding, alternate exterior or vertical there. But its relationship to 1 is alternate exterior. Now when I look at this section, I'm corresponding, I'm alternate exterior. I can't really jump from here to here with one of those, but I do know that angle 3 is congruent to angle 11 because it's corresponding, and angle 8 is corresponding to 16, so they're congruent. So they're going to be congruent to angle 11 by the transitive property of congruency. So here are all the ones that are congruent to angle 1 and the reasonings. These were listed on the PowerPoint, and they do not apply here. Angle 1 and angle 4 are same side exterior angles, but that does not make them congruent. It makes them supplementary. And 5 and 10 are alternate interior angles and are congruent, but they have nothing to do with angle 1. So now let's work some examples. If the measure of angle 4 is 110 degrees, what is the measure of angle 7? So I first look at 4 and 7. I know that 4 and 5 are congruent, and 5 and 7 are a linear pair. So that makes, if this is 110, this is 110, now I have a linear pair here, so the measure of angle 7, I'd have to, what can I add here to this to make it 180? Has to be 70 degrees. All right, if the measure of angle 2, let's change colors for this one. Measure angle 2 is 75 degrees. What is the measure of angle 8? Well, 2 and 6 are corresponding, so I know this one is 75, and I know it's a linear pair here, so I'm having to think, okay, well, what's 180 minus 75? And that would be the measure of angle 8, 155 degrees. Oh wait, I think I don't, 100 and, yeah, no, did my subtraction wrong. Okay, so I've got 180 minus 75, it's going to be 105 degrees. Okay, now let's take a look at number 3. Change colors again. If the measure of angle 5 is 2x plus 5, so 2x plus 5. I like to be visual with it. The measure of angle 3 is x plus 25. These are same side interior angles, so they are going to be supplementary. So that means I can add those together and solve for x. So I have 3x plus 30. So I know that x equals 50. So I've answered this. Now what is the measure of angle 4? Well, angle 3 and angle 4 are linear pairs, but remember, angle 4 is alternate interior to angle 5. So I know that the measure of angle 4 equals the measure of angle 5, alternate interior angles. So let's see, the measure of angle 5 would be 2 times 50 plus 5. Measure of angle 5 is 105 degrees. So that means the measure of angle 4 is 105 degrees. Okay, moving on to some more examples here. If the measure of angle 4 is 77 degrees, and the measure of angle 8 is 4x plus 57. These are corresponding, and that makes them congruent. So I would set them up equal to each other. Solving for x. Move on to the next one. Looking at measure of angle 3 and measure of angle 5. 3 and 5 are alternate interior angles, which makes them congruent. Notice how I'm always looking at the relationship first and what that relationship means, and that helps me set up my algebraic equation. Measure of angle 1 and the measure of angle 7. 1 and 7 are alternate exterior angles, which are also congruent. Now I know I can set them up to equal each other. There we go. Okay. Let's take a look at one more set of problems, or two more sets of problems, sorry. With this one, Now these lines are obviously not parallel, but I'm going to say that T is parallel to S. I need to have that before I can solve these. Measure of angle 2 is 97 degrees. Measure of angle 6 is 83 degrees. Well, I can go verticals and alternate interiors and verticals. And then I look at my linear pairs and I think, okay, 180 minus 97, oh, that's 83. And verticals, alternate interiors, and verticals. Linear pair here, that makes that 97. So now I can do my verticals, alternate interior, and my verticals. I'm going to go ahead and label them all right here on the diagram. So now this makes it a pretty easy problem. I just have to read them right off the diagram. So I've got 97 degrees, 97 degrees, 83 degrees, 97, 83, and 97. Okay, when I'm looking at this one, I've got some notation here that tells me that this line right here is parallel to this one. The first thing I want to use is triangle sum theorem. Every triangle has 180 degrees in it, so 180 minus 65 minus 53 makes this 62. And then notice I've got parallel lines and a transversal here. Y is alternate interior with this angle, so Y is 62 degrees. Then I have to kind of really think about it a little bit for X, but I've got this angle of 65, 62, and X, which I'm going to call a linear triple. So I take 180 minus my 65, minus my 62, and I come up with that X is 53 degrees. For the last problem, I'm being told that AB here is parallel to DC. So I'm going to look at, this is a transversal of these parallel lines. It's really hard to draw on this slate. So that makes all of these 90. Well, 3x corresponds to this 90-degree angle. So I know that 3x equals the 90, so x equals 30. Then I'm going to go look at the other one up here where I have to solve for y. This is my transversal here. These are same side interiors, so that I know my y minus 10 plus 100 equals my 180. So y plus 90 equals 180. Y equals 90. When you think about it, that's going to make this 80 degrees. That's 100. This one is 90, and this one is 90. When you add them all up, you get 360 degrees, which is correct for any quadrilateral. All right, so we've played around with some algebra with parallel lines and transversals. If you have any questions, please reach out through It's Learning or in class, and I hope you have a great day. Thanks.